It's a great morning in the United States. It's a little later in Europe, and it's getting into evening. So this is December 22, 2025, and it's once again we are back from the Partha Ghosh School of Leadership, one of its kind in the IIT system at Indian Institute of Technology, Kharagpur. So we have the immense pleasure to host one premium monthly talk given by an expert of huge repute, international importance, and global repertoire. So today we are really happy to have one such personality whom at a very personal level I also know and very intimately because of his immense embrace and love and concern that he has for the Indian universities. So before I start off, I'd like to read out just a few lines which Dr. Partha Ghosh has sent me. He's the patron of the school. He's a Sloan Management graduate from MIT, Boston, New Cambridge, and he is also distinguished alumnus of IIT Kharagpur, and he has really given his heart and his wealth to the making of this school. So he says, greetings from California. My heartfelt thanks goes to Professor Dr. Ernest Fryar. And he says, as I prepare for takeoff, he's heading for California, I felt compelled to share a few reflections on what may well be the most consequential subject of our time. He says, perhaps the most profound challenge civilization has faced since its earliest beginnings confronts us today. We have fundamentally disrupted the relationship between humanity and nature, between humanity and environment, between humanity and ecosystems and everything that's built within it. Despite extraordinary technological advances and a deeper scientific understanding of nature's laws, we have consistently failed to harness these capabilities to cultivate a more enlightened relationship with nature. This failure, I believe, defines the central deficit of our time, a deficit of leadership. And for this, we look forward to Professor Ernest Fryar's distinguished talk today. So it is the responsibility and the challenge which the School of Leadership at IIT Kharagpur which has taken up. And it is in this line we look forward to a leadership that fuses Eastern and Western philosophical traditions of nature, environment, earth sciences, ecology, and of course, the paradigm concept of sustainability. So only through these shifts, he says, Dr. Ghosh says, can humanity foster a more collaborative relationship amongst nations, among communities, across disciplines, and most importantly, with our shared ecosystem, which is Mother Nature. So with these reflections, I very much look forward to an enriching session with Professor Dr. Ernest Fryar and the dialogue that will flow from this point onward. So it is our extreme pleasure to invite on floor Professor Saibal Gupta, who is a renowned senior professor of the Department of Geology and Geosciences, and he also heads as Dean of the Faculty of Sciences of IIT Kharagpur. Just to read a few words about Alan, I think a few words does not justify what he is as an expert, as a person, and as the guru of many of us who are sitting here. Yeah. So it's over to Professor Gupta to kindly read out a few words to describe the great life and career of Professor Fryar. Over to you.
Thank you, Professor Sen. Can you hear me?
Yes, absolutely.
Yes, okay. So it's indeed a very great pleasure for me to formally welcome Professor Ernest Fryar to deliver this particular lecture. It's part of a series, as Professor Sen has already pointed out, of a unit, an academic unit, which actually tries to generate leadership on various issues that concern mankind. And there is no better person to actually address the issues that Professor Fryar is going to raise than himself at this moment. So for those who are not acquainted with Professor Fryar, he is a very renowned professor of Earth and Environmental Sciences in the Environmental and Sustainability Studies program at the University of Kentucky. He does a number of things. He is a hydrogeologist. He does hydrology. He does environmental geology. His research interests, they include groundwater flow, water quality in Kentucky, other parts of the USA, and many other developing countries in Africa and Asia. And the ones in Africa that he has talked about, I know, are in Morocco, is a very prominent one that I know about. And indeed, he, along with his very eminent pupil, who happens, we are fortunate enough to have as our colleague, Professor Abhijit Mukherjee, have also been working in Asia on various aspects of groundwater problems that concern the Indian subcontinent. So much of what Professor Fryar has done, it focuses on how, when, and where groundwater is recharged. This is important information for understanding the changes in the availability of water resources in this immensely challenging climate change scenario. Professor Fryar did his BS Cum Laude degree from Duke University in 1984, his MS in Geology from Texas A&M in 1986, and his PhD in Geology from the University of Alberta in 1992, working with F.W. Schwartz and J. Toth. He has a number of laurels that he has been honored with through his career. So to name just a few of them, he was a Davidson Fellow at the Graduate College in Texas A&M from 1984 to 85. He was the W.G. Mills Memorial Fellowship holder in hydrology at the Texas Water Research Institute, Texas A&M, 85 to 86. He was a Fulbright Research Scholar in Morocco from January to May 2014, a Fulbright Specialist in Environmental Science in Pakistan from December 2009 to 2010, and in India from February to March 2017. The George Burke and Maxey Distinguished Service Award of the Hydrogeology Division of the Geological Society of America in 2019. Sigma Xi, the Scientific Research Honor Society in 2021. He was also awarded the James B. Thompson Distinguished International Lecturer Award for the Geological Society of America in 2024 to 25. He's a member of a number of different and important organizations. He has published a very large number of papers, which I couldn't really count through them. He hasn't numbered them, but I'm aware of many that I myself have had occasion to read through. He has been employed after completing his PhD in 1992. He was a research associate at the Bureau of Economic Geology in the University of Texas at Austin. He was at the Kentucky Water Research Institute from 1995 to Jan 1999. He was at the Department of Forestry and Geology at the University of the South Seventy, Tennessee as a visiting associate professor from August 2006 to May 2007. But he has been consistently in the Earth and Environmental Sciences department. It was, I think, formerly called the Department of Geological Sciences. This is at the University of Kentucky. He is a professor since 2019, but he had joined there initially in 1995. So given the range of things that he does, he has been as a faculty fellow, to speak recent things that he does, is a faculty fellow of the James B. Beam Institute of Kentucky Spirits, a Kentucky Climate Consortium person in the Kentucky Climate Consortium from 2021, and he's an affiliate of the Kentucky Water Research Institute from 2023 to the present. Today, he will be talking on advancing sustainability by different ways of understanding Earth systems. And the fact is that we know Professor Fryar's connection with IIT Kharagpur since long, but the one that is rather poignantly I remember is that we had an Earth Science seminar in March 2020 hosted by the Department of Geology called Prithvi. And when that was going on, he gave the inaugural lecture, and immediately after that, we got the information that we had to close down the institute because of the pandemic. So that was an interrupted association, but I'm very happy to note that since then, Professor Pryor has been with us in our department on several occasions. He's been supporting us in various ways. And today, he has graced us at this platform of ours, which is one of our premier platforms, to talk about this to the rest of the world. So, Professor Pryor, it's open to you now, please.
Thank you so much, Professor Gupta. So it's over to Professor Fry. It's a pleasure. And if you have any presentation, yeah, there it's visible. Yeah, great.
Excellent.
Yeah. Excellent.
Well, thank you very much. I'm honored to be invited to speak today. In fact, my connection to IIT Kharagpur, although I did not visit Kharagpur until 2017, goes back to 2004 when, with my then PhD student and now longtime colleague, Professor Abhijit Mukherjee, had the opportunity to collaborate with the late Professor Amitava Chakrabarty, who was the head of the Department of Geology and Geophysics, and he really helped to facilitate my collaborations in West Bengal and in India more broadly, and I'm indebted to him for that. And it's wonderful to see all of these longtime colleagues who are here with me, and I'm grateful to Dr. Partha Ghosh for underwriting this lectureship series and the School of Leadership, and to Professor Joyshen and to Dean Saibal Gupta and Professor Mukherjee for helping to arrange this presentation. So big word, but this is going to be a bit of an idiosyncratic talk. When I was asked to put this together, I really wrestled with how to do this, but I appreciate Professor Gupta's introduction in part because he kind of gave the spoiler alert that I'm going to be focusing in part on talking about groundwater recharge, which is a lot of what my research is focused on over the last 25 years, but in the broader context of how we understand Earth systems and how that can lead us to advanced sustainability. And so this starting photograph here is something I found from Wikimedia, which is a photograph of a famous step well, which unfortunately I have not visited in Karnataka, but I think it's reflective of the millennial scale genius for water management in India, and the fact that these features, which were designed so efficiently and so beautifully for multiple purposes centuries ago, in a number of instances, are still functioning. So this was the charge I was given from Professor Joyshen in his email about the fact that there is a division of knowledge between formal and traditional understandings, ecological collapse, moral drift, and widening inequality, and a lack of leadership in every domain. Institutions around the world need to be guided more by wisdom, by compassion, and by a shared purpose. And it's important to recognize that ecological interconnectedness and living habits are founded in part on an understanding of earth and environmental sciences. And he posed the questions: who leads the way toward a safer and greener future, and how? And I'll try to address that by example and by discussion of some individuals, as well as sort of collective responsibility through this talk. So my outline is to talk, first of all, about linkages between climate change and the water cycle, and some of the complicating factors that make this, as we would say, a wicked problem. I want to speak briefly about the United Nations Sustainable Development Goals and how they're related to water, talk with particular reference to my colleague and Professor Mukherjee's postdoctoral mentor, Bridget Scanlon, about work on global water resources and the role of groundwater, and then lean into talking about groundwater recharge, and then discuss examples of traditional knowledge, adaptation, and use of technology, and how these various examples illustrate ways forward, but recognizing that infrastructure and technology themselves are not enough. And finally, where do we find common ground and hope? So this first diagram is actually from Scanlon et al. And Professor Mukherjee was one of multiple co-authors on this review, talking about water utilization and the role of groundwater. And this is just a diagram, as many of you maybe have seen at various points through your education, about the water cycle. But what's interesting here is this really puts emphasis on human interventions in the water cycle. And so we see aspects here like precipitation, for example, and I'm circling this with clouds, also snowpack and snowmelt, and we can see aquifers beneath the ground. But we also see features here like recharge basins and injection wells. So this leans into talking about the role of humans in augmenting natural processes such as replenishing of groundwater, as well as interventions such as not only engineered interventions such as water transfer megaprojects, but also looking at virtual water trades. So in terms of talking about linkages between climate and the water cycle, we've known since the work of Svante Arrhenius in the late 1800s that a warmer atmosphere holds more water vapor. This is not new science. This is simple physics. And so this means, so to speak, wetter wets and drier dries. And as a result of climate change, various places on Earth are projected to or are becoming wetter or drier overall, but the extremes are intensifying. And this has implications for water, both from a perspective of hazards such as storms and resultant floods, landslides, which can be triggered by storms, and droughts, but also water resources. For example, river flows, lake levels, and groundwater recharge. And I'll talk more about recharge in particular later. So this is just a photograph from June 2022 taken from the Down to Earth website showing flooding in Assam following drought. So this is reflective of sort of the climate whiplash we see in places where extended unusually dry periods are followed by intense rainfalls. And in terms of talking about sort of the antithesis of too much precipitation, drought is defined as unusually dry conditions relative to whatever a normal baseline is. So dry areas such as shown in the southwestern United States and Mexico, in parts of South America, particularly deserts along the Pacific coast, in North Africa and the Middle East, sub-Saharan Africa, parts of the Indian subcontinent and Central Asia, parts of the European basin and Australia. These are all places that are dry anyway. But climate change is amplifying this issue. And so from the perspective of water scarcity, which I believe is defined by the United Nations as per capita water availability as below 1,000 liters per person per year on average, you can see the darkest color is that year-round we have water scarcity at the limit in these dry areas. So when I talk about complicating factors, among them are that it's difficult to disentangle water quality issues from water quantity issues. And so, for example, when there is flooding, there can also be waterborne diseases. In coastal areas in particular, where there is overpumping of groundwater, that can reverse the flow of groundwater toward the sea, and we can have saltwater intrusion. And in areas such as in Alaska or in the Andes in South America, where permafrost, which is permanently frozen ground, or where alpine glaciers melt and recede, not only can that affect the availability of water, but the exposure of bare rock can also lead to oxidation of minerals that generate acidity and can mobilize heavy metals, thereby causing what we call geogenic pollution of water supplies. In terms of human activities, we can't really disentangle human activities from what happens in terms of our ecosystems. And so changes in land use and in land cover, such as from deforestation or urbanization, can amplify the effects of climate change. So, for example, urbanization can result in an increase in what we call impervious cover with more roofs and pavements, and that means there will be less water to infiltrate and more water running off to surface water bodies, potentially carrying pollutants with it. Population growth, as well as economic development and associated groundwater depletion, particularly for irrigated agriculture, can increase water demand. And finally, efforts to ensure conservation of water can run afoul of management factors such as water and electricity pricing. So, for example, it's been noted that in various states in India, electricity rates have been kept relatively low in order to provide aid to farmers who are using electric pumps to pump groundwater, but that is an economic disincentive to water conservation. And in some instances, local water laws basically promote use of as much water as possible by the rights holders. So just in terms of talking about the example of flooding and water pollution, these are two photographs I took with one of Professor Mukherjee's students, David Eind, on Majuli Island in Upper Assam in the Brahmaputra River Valley. And you can see at left a man standing on a platform. You can see houses here are on stilts, so they're used to flooding, but he's pointing to a high water mark above the platform of the house. And at right, you can see that a road on the island is built up on an embankment, but the hand-pumped tube well at right for one of these houses is actually below the embankment. And so that's going to be inundated for extended periods of time with flooding, particularly during monsoon. And thereby, polluted water can potentially move down within the tube well and cause exposure to waterborne diseases. This is now famous GRACE satellite image from studies done by Matt Rodell and colleagues at NASA. And this basically shows how the equivalent water distributed throughout the subsurface in northwest India and eastern Pakistan has been depleted by groundwater pumping. And this is simply over a 6-year period from 2002 to 2008. But this is an ongoing problem. And a lot of this is for irrigated crop production. And an example of this is a photo that I took from the side of the national highway showing a sugar mill in Uttar Pradesh. And cane is one of these crops that's high value, but particularly water intensive. So in terms of the Sustainable Development Goals, when we talk about water, we particularly tend to focus on Goal 6, circled to the right here, which is clean water and sanitation. But in fact, directly or indirectly, water bears on virtually every other Sustainable Development Goal. And Professor Mukherjee has actually edited a book volume talking about the SDGs and implications for water. And so, for example, if we think about the fact that in less developed countries where there is not water available at households or nearby, that is often women and girls who are responsible for fetching water. That's a source of gender inequality, which is SDG 5, and that impacts on availability or opportunity to attend schools and thereby quality education, which is SDG 4. And this is just a photograph taken by my colleague from Niger in North Africa, West Africa, Professor Ali Mamouni, showing women collecting water from a dug well near the town of Dakoro. In terms of the paper that I mentioned, the review by Bridget Scanlon and others, Global Water Resources and the Role of Groundwater, that paper makes several salient points in terms of what we can try to do to address some of these challenges. So fundamentally, water scarcity can be combated through more sustainable water use. And sustainability in the context of water is really defined as development that can be maintained indefinitely while minimizing adverse social and economic and environmental impacts. But with particular reference to water, more sustainable water management requires integrating multiple dimensions of water security while at the same time recognizing trade-offs. And so these dimensions include both human and ecosystem health, environmental and social justice, climate adaptation, because as has been observed, the target for warming above the pre-industrial baseline of 1.5 degrees Celsius is pretty much baked in at this point. And while doing all of this, it's necessary to satisfy competing sectoral demands, such as agriculture, industry, and energy. And so we can think of resilience. And in order to strive for resilience, it's really necessary to develop a diverse portfolio of solutions. And historically, we've looked to engineered solutions, what we might call gray solutions. And moving forward, approaches that are engineered include increasing supplies, and examples include desalination and wastewater reuse, enhancing storage in surface reservoirs, but it's well known that dams and reservoirs can cause not just displacement of populations in dammed areas, but adverse downstream ecological impacts as well. Enhancing storage in depleted aquifers, I'll talk about a little bit more in terms of groundwater storage. And finally, transporting water. This is something that's been done for millennia in some instances in hydraulic civilizations in places like China. More recently, and this is sort of back to the future, as it were, we can look at nature-based solutions. And really, these include things like forest and wetland preservation, but also stream restoration. And finally, from a management perspective, it's important to manage groundwater and surface water as a single resource. But the challenge is they might be regulated separately. So in the United States, for example, we have surface water, depending upon whether or not you're talking about streams that cross jurisdictions, that is state boundaries, may be regulated at the state level. The federal government intervenes when you're talking about transboundary rivers. Groundwater tends to be regulated separately from surface water, but they're clearly connected. And then another issue is regulation of water quality, that is water pollution, which has really been driven by the federal government as opposed to water quantity or water resource utilization, which is really regulated at the state level. So this is a complicated set of knots to disentangle. So specifically talking about groundwater recharge, we can define that as the replenishment of groundwater by infiltration from the land surface to the water table, basically the upper surface of the saturated zone where all the space underground is filled with water. And oftentimes, if you ask a person on the street, as it were, what is groundwater, they might think of underground streams or underground lakes, but in fact, typically we're talking about spaces between grains of soil or fractures in rock. This infiltration from the land surface can also be engineered by humans, what we call artificial recharge or managed aquifer recharge. And I'll talk a little bit more about that later. Part of this artificial recharge, too, can actually involve direct injection beneath the water table. Naturally, the rate of recharge varies with precipitation or in areas with mountain water towers, as we say, such as in the Himalayas, with rates of snowmelt. The rate of recharge also, once water has infiltrated, varies with the hydraulic properties of the soils or sediments or rocks. When pumping exceeds recharge, groundwater depletion occurs, and that really hasn't been an issue until the advent of mechanized pumping, starting perhaps 100 years ago. And for a while, there was a concept of safe yield, the idea that, well, if you don't exceed the rate of recharge when you pump, then that's sustainable. But that has been shown to be a fallacy because that doesn't allow for what might be thought of as excess water to discharge to streams. So what sustains streams when there are not periods of rainfall is groundwater seeping into those streams. And Professor Mukherjee and his group in part have looked at that and the impact of pumping in Ganges Valley on lowering stream flow. And this sort of discharge occurs not only to streams, but also to other surface water bodies such as lakes and to the ocean. So just a couple of case studies that I think are useful by Scott Jasechko, who's now at the University of California, Santa Barbara. These are from about a decade ago, and Scott tends to work with big data and machine learning with his collaborators. The first of these studies, which I believe was from his PhD work, was looking at global groundwater recharge and the seasonality of that recharge. And just for context, groundwater recharge by precipitation provides 2 billion people with drinking water and supplies 40% of the water used for irrigation for crops globally. And what Scott and his colleagues found is that arid and temperate climates typically tend to have recharge focused in the wintertime, when basically precipitation exceeds water losses back to the atmosphere by evaporation and by transpiration from plants. But in the tropics, where you tend to have not so much cold versus warm seasons, but wet versus dry seasons, recharge tends to be at a maximum during the wet season. The second of his studies looked at long-term tropical groundwater level records, and what he found was that recharge is disproportionately from heavy rainfalls above some threshold, and that threshold may vary depending upon where you are. But what this says is that even if you have a succession of dry years, if you have a relatively intense period of precipitation, that may be sufficient to provide substantial recharge. And so one of the silver linings, if you will, with global warming is that intensification of precipitation in the tropics may favor, emphasis on may, groundwater replenishment. And this is just a diagram from the first of the papers from Jasechko and others that I mentioned, showing the division of annual recharge versus precipitation. And you can see that that ratio of recharge to precipitation is as much as 25% in more humid areas, such as in Eastern North America and in much of South America and Sub-Saharan Africa and Southeast Asia. And there are other places where there's just not much modern recharge going on. They tend to be relatively dry, such as in parts of Australia, the Arabian Peninsula, South Africa, and Western North America and South America. So let me talk now about examples of where traditional knowledge and traditional technologies, if you will, are still being practiced and successfully so. So one of these is the technology of acequias in southern Spain. And you may be familiar with the fact that southern Spain was sort of the farthest part of the Arab Empire for about 700 years. And so this term acequia comes from the Arabic asakia, I hope I'm saying that correctly, which means water conduit or water bearer. And these are earthen channels that are dug into sides of the mountains in the Sierra Nevada in southern Spain. And this was a 3,000 kilometer irrigation network built by what we call the Moors, basically people who came from North Africa, from places like Morocco, between the 8th and 10th centuries of the Common Era. And southern Spain is semi-arid. This is actually the oldest aquifer recharge system still in use on the European continent. And it involves diverting spring snowmelt from stream headwaters into these channels that may be tens of meters to kilometers long, and they're gently sloping, and they are dug to flow to areas called semas, which are in upper valley regions where water infiltrates. And this, in turn, feeds springs and streams that emerge farther down the mountainsides and provide water supply for communities and for small-scale irrigated agriculture. So this is actually from a article on the BBC website from several years ago, showing one of the, I believe the term is asaqueros, one of the traditional knowledge keepers, who helps to keep these channels operational. And part of the challenge here is, first of all, a change in precipitation regimes with global climate change, that the Mediterranean basin, including southern Spain, is getting warmer and drier, and so there is less snowfall and therefore less snowmelt for infiltration. But also the fact that this is a technology that is centuries old, but it's necessary to continue to train younger people in these practices. But there's been a lot of depopulation in this region as people move to cities. And also, this type of technology is not as much prioritized where there is intensive cropping for vegetables in lowland regions of southern Spain. And interestingly, at the same time, there was similar technology, sort of parallel evolution, that was developed in the Peruvian Andes by pre-Incan peoples. And these are called amunas. And this was actually developed even earlier during the 7th century of the Common Era, 800 years or more prior to European colonial contact. And this is part of effort to enhance water supply for the city of Lima. So more than 50 kilometers of channels have recently been rehabilitated to capture rainfall in the Andes Mountains and divert it for infiltration. And this is an efficient but low-cost implement to the dams and reservoirs that provide water to Lima, which has a population of 10 million, and after Cairo, Egypt is the largest desert city in the world. Lima is second. And average rainfall is only about 8 millimeters a year around Lima, and that only falls during about 4 months. So really, Lima relies on water from the mountains. And this is just a photograph. This is taken from the Nature Conservancy's magazine of public information campaign showing the effort to rehabilitate these historic diversion channels. And then finally, very recent from an article this month, smaller scale, but perhaps indicative of something that can be replicated locally in various places, is spring restoration in the state of New Mexico in the Southwest USA. New Mexico has a relatively large number still of indigenous people. And in this one community called Zuni Pueblo, Pueblo is one of the traditional indigenous communities, and Zuni is a particular Native American tribe. There's a spring that dried up. And this is really being seen throughout the southwestern United States as a casualty of what's been called a millennial scale mega drought, that is the driest conditions in over 1,000 years. And a particular farmer who grew up learning about various indigenous understandings of water in the community noticed a nearby site close to his field that was covered with dry grass. And this site had a traditional name in Zuni that referred to water. And he excavated the dry grass and found the water table at less than half a meter below land surface. And in exposing this seep, he's provided wildlife habitat as well as water for gardening using traditional techniques. But this is part and parcel of the ancestral Pueblans, the indigenous people, having a cultural memory of being able to weather to survive and adapt through extreme droughts over the last 1,000 years. And this is consistent with scientific data such as tree ring analyses from the region. So this is a picture of this farmer from the Zuni tribe, Jim Inote. And as I said, this is from this month's issue of Sierra magazine from the Sierra Club. And his seep is shown down here at the bottom. So we can talk now about modern adaptations to some of these water challenges in an intensifying climate. This includes flood recharge. In California, California is really the vegetable basket of the United States, and irrigated crop production for fruits and vegetables and grains since the early 20th century has caused major depletion of groundwater in the Central Valley. And in some areas, there's been greater than 9 meters of land subsidence, and this has been described as one of the largest human modifications of Earth's surface. And so in some instances, in part for economic reasons, just because of costs of pumping, some farmers are fallowing fields, choosing not to grow. And for example, with rice farming, this can be done over several seasons or several successive years. It's harder with investments for example, almonds for tree crops. And in the process of fallowing, farmers are creating ponds and ditches to capture rainfall for infiltration. And this has really risen to the fore during the last decade as there's been intensifying flooding associated with storms that are called atmospheric rivers, where following dry periods, there are just days and days and days of rain. And this is not a monsoonal climate, but it is a Mediterranean climate where there is a distinct wet season during the wintertime and about 9 months of dry season. And so this flood recharge is being facilitated by the state accelerating the process of permitting groundwater recharge, of permitting these captures. And farmers are actually being incentivized, being paid by water agencies to do this. So it's kind of a win-win in terms of flood mitigation and groundwater recharge. So this is just a photograph from Inside Climate News showing the Pajaro Valley in California near the city of Monterey after one of these atmospheric rivers in March of 2023. Another way that artificial recharge is being performed, and again, kind of a win-win, is wastewater recharge. So in the state of Virginia, in the eastern USA near Washington, D.C., groundwater withdrawals are depressurizing deeper confined aquifer, so not the shallowest or water table aquifer, but deeper down. And this is causing land subsidence. And this is particularly a problem. The magnitude of land subsidence is not as great as in California, but this is in a coastal region where there is ongoing sea level rise, a half meter in the past 100 years. And so there are concerns with flooding, but also with saltwater intrusion as sea level rises into shallower aquifers. And so treated wastewater is being re-injected into this deeper aquifer. And in the current pilot project, the injection rate is 4 million liters a year, but they're planning to increase that by 100-fold by 2032. And the win-win here is not only does this conserve water, but it also reduces nutrient loading to estuaries, particularly to Chesapeake Bay, which is a major fishery on the East Coast. So this is just a photograph of the pilot treatment plant in this region, taken from the New York Times. And this water is basically sewage that has been treated to drinking water standards by various filtration technologies and then ozonation for disinfection before being reinjected. And then finally, technology has provided benefits as well. And so one example is machine learning with satellite data. And so I alluded to some of the work that had been done by Scott Jasechko and colleagues earlier. What I want to highlight now is a study by Rhoda and others published last year in Nature, mapping groundwater-dependent ecosystems in drylands. And this work was done globally at approximately 30 meters horizontal resolution. And in this process, they identified groundwater-dependent ecosystems on almost a third of global drylands, including biodiversity hotspots. Now, a number of these groundwater-dependent ecosystems probably existed previously, but are no longer present because of pumping, for example, for agriculture, lowering the water table. Therefore, they found that groundwater-dependent ecosystems now are more widespread in landscapes that are dominated by pastoralism, by grazing, because there are lower rates of groundwater depletion. And so these landscapes tend to be more sensitive. More than half of the mapped groundwater-dependent ecosystems exist in areas with declining groundwater trends, and only about a fifth exist on protected lands or in areas with sustainably managed groundwater. So this provides kind of a pathway forward, a template for helping develop new policies and mechanisms to protect these sensitive areas. And so this is just taken from Rhoda and other studies showing this map of global groundwater dependent ecosystems. And again, they're focusing on dryland areas because it's difficult to use these satellite data to map groundwater dependent ecosystems in wet areas such as the humid tropics. Another application of technology relatively recently, 2 different studies using different geophysical methods to identify the occurrence of submarine fresh groundwater in volcanic islands and in deltaic shorelines. So a study has been done by workers at the University of Hawaii, and this builds on indigenous knowledge that Polynesians, the original humans who came to Hawaii, used freshwater springs along the coastline. And this is a volcanic archipelago in the middle of the Pacific prior to European settlement. And this study used marine electromagnetic surveys using towed geophysical sensors, and they identified fresh groundwater flow fairly far offshore, and it appears to be occurring through the submerged flanks of a volcano toward submarine vents where springs occur. And closer to you all, Lee and others in a paper that just came out this fall in Nature Communications used a slightly different geophysical technology with magnetotelluric soundings in the Ganges-Brahmaputra Delta, and they identified 2 large confined freshwater bodies, which appear to have formed during the last glacial maximum, the last ice age, and the concurrent low stand of sea level. So these technologies show promise for delineating fresh groundwater for new water supplies in other volcanic islands and in deltaic coastlines. So this photograph just shows some of the electrical resistivity profiles that were done in the study off the what's called the Big Island, the island of Hawaii in the state of Hawaii. And the blue here shows the areas that tend to have the lowest conductivity or the highest resistivity, indicative of fresh water. And then at left is a diagram from the study in Bangladesh showing boreholes and areas where the geophysical surveys occurred down one of the distributaries in the delta. And you can see that the lighter sort of yellow colors here indicate fresher water. And this is important because, as shown at right by this photograph from the Sundarbans, sea level rise imperils fresh groundwater, shallow fresh groundwater. And again, Professor Mukherjee and his students have been involved in working on this on the Indian side. And so finally, a caveat is really infrastructure and technology, the so-called hard solutions, are not going to be enough to solve water problems. And I'd like to highlight this book published a couple of years ago by Peter Glick, who is a well-known thinker about water issues, called The 3 Ages of Water. And he points to what he calls the 3rd age of water. We're in the 2nd age of water, the late 2nd age right now. The 2nd age really focused on traditional kind of hard path approaches, such as physical infrastructure and large institutions. So dam building, aqueducts, centralized water management agencies. And these have obviously provided important benefits in terms of economic development and human health. But infrastructure is aging, it's expensive, benefits were unequally distributed, and it relied on what Glick calls ecologically damaging, socially disruptive, and capital-intensive approaches. And so his keys to what he calls the soft path forward in the 3rd age is, first of all, we have to recognize the human right to water and focus on meeting water-related needs. Second, we have to recognize the true value of water, that water falling from the sky is not a free good. It has inherent value for humans and for the environment. That we have to protect ecosystem health by guaranteeing basic water supply and quality needed, and by restoring ecosystems. This gets back to the nature-based solutions that I talked about. We have to maximize the social and individual well-being from every drop of water that is used, and finally put treated wastewater, gray water, or stormwater to use. And I've showed some examples of that previously in terms of managed recharge. So finally, where do we find common ground? Where do we find hope? And I would articulate in part through faith. I'm a person of faith. I'm a Christian. I'm an Anglican. I would argue that faith and science are not necessarily incompatible. At the same time, I recognize that it's important to engage people who have no faith tradition as well, but who are socially concerned. So we can consider the role of water in major religions, in Christianity, in Islam, and Hinduism, for example. And I'd like to highlight the thoughts of the Indian writer Amitav Ghosh from his book, The Great Derangement, which was actually given to me as a present by students and teachers at DAV school, IIT Kharagpur, when I visited in 2020. Ghosh says the most promising development, in his view, is the growing involvement of religious groups and leaders in the politics of climate change. And he says it's impossible to see any way out of this crisis without an acceptance of limits and limitations. And he says he thinks this is intimately related to the sacred, however one may wish to conceive of it. And so just for photos that I took earlier this year, in Christianity, water is essential in the rite of baptism by which one is declared to be a Christian. And this is a baptistry where people were immersed. This is at the historic Church of the Virgin Mary in Ephesus in Turkey, which is one of the places the Apostle Paul visited. And this church is over 1,500 years old. This is also a photograph, when we go back, from Turkey, from a fountain outside the Hagia Sophia Mosque in Istanbul. And water is important in part for purification in Islam prior to prayers. And of course, water is essential for worship. The Ganges is considered a deity. And water is important in funeral ceremonies. So this is just a photograph that I took of a crowd gathering for the evening arti in Haridwar. So a little bit more about human perspectives. Amitav Ghosh talks in particular about the late Pope Francis and his encyclical Laudato Si, published 10 years ago. Pope Francis took his name from Francis of Assisi, who lived about 1,000 years ago. And Pope Francis says that St. Francis helps us to see that an integral ecology calls for openness to categories transcending the language of mathematics and biology, taking us to the heart of what it is to be human. And he says the climate is a common good. A prominent atmospheric scientist here in the United States is Dr. Catherine Hayhoe, is the chief scientist of the Nature Conservancy, but she's also an evangelical Protestant Christian. And a profile of her in the University of Illinois Alumni magazine highlights that she says climate action starts with conversation, and love for others, for the planet, is the most powerful motivator of all. I'd like to wrap up then with thinking about indigenous perspectives. So Tom Gleason, who is really a big picture thinker about a lot of these issues at the University of Victoria in Canada, is working with colleagues at his university and with Indigenous people in the Cowichan tribes in a watershed-based study on Vancouver Island. And one of their papers published this fall says that knowledge is generated through relationships with land and is inseparable from the lived responsibilities and rights rooted in that place. And the Zuni farmer I highlighted before has been a farmer for 70 years in his community. And he says native traditional knowledge has a climate insight. So climate science should not just include native or indigenous knowledge, but begin with it as a foundation for understanding the way the world changes. It's not just about climate resilience. I use the term climate reverence to shift from technical to relational language. That way we honor climate and land as kin and not as commodities. So closing thoughts, finally, from an article in EOS, Accelerating Toward Water Security, where there was a relay, simultaneous, basically 24-hour discussion around the world talking about how to address these issues. The take home was that solutions cannot be one size fits all, but have to be tailored to local situations. And the participants highlighted that local communities, including indigenous stakeholders, have to be engaged and empowered so that their own knowledge is embedded in solutions. And finally, this is intergenerational. Water has to be part of education curricula at all levels and in all disciplines, not just those in traditional scientific and engineering domains. So I will stop with that, and I am happy to talk further.
Yeah. Thank you so much, Professor Fryar. I think it was a touch of wisdom, just not the brain speaking of yours, but also the heart, your experience all over the world. I think the whole presentation was like a crescendo. It just went up and up and up into the larger thoughts of freedom, embrace, and understanding water, not as an object of technology and science, but as a armature of reverence and as a connectivity between human beings and nature. I think I'm not very sure. I think Dr. Ghosh Dr. Partha Ghosh is here. I can see his name. I know he's traveling to California.
Yes, I'm here.
Yes, Partha. So
Yeah,
Alan is here, you are here, and absolutely delighted, absolutely inspired by the talk, and especially
yeah,
the last 15 slides. It reached a crescendo. It was like music, avatar, the avatar of water. Yeah. So, Dr.
absolutely.
Ghosh, we'd like to hear from you. Maybe we can begin with you. That'll be a pleasure.
Absolutely. First, a very, very thankful to Alan. Alan, it was a wonderful presentation which covered so many different dimensions across boundaries, geographical, age. I particularly connect with your point, third age of water, and how that connects with literally the sacredness with which we have to manage our relationship with nature. And you have highlighted that perhaps which would be the most important requirement of the 21st century. I particularly appreciate that you talked about it has to be part of the education curriculum, where how we treat water as a sacred flow as opposed to an object or a molecule. I think that has to be particularly brought in the forefront. So I think that's why we think the leadership in the 21st century should be able to connect all the different dots, which on the surface are not connectable, but we have to be able to uncover our creativity to be able to connect the dots. In the process, connect the sacredness of nature with the scientific understanding of how the world has shaped in the last 21st century. Particularly, I appreciated when you talked about, as I always say, divinity and digitization are not in contradiction with each other, they support each other. But that needs a different kind of thinking, which I often call the plus sum thinking. How do we synergize multiple streams of thoughts which on the surface might look they're in conflict with each other, but at the end they all connect and they come together. So I'm absolutely impressed. I hope we will continue to be part of the leadership movement which IIT Kharagpur has begun. I'm also part of the Tufts University leadership movement. In fact, I'm so glad one of my colleagues, Dr. Sam Ligero, is also online. He's very much leading the effort on what we call engineering leadership. So I think it's the beginning of a new movement. And Dr. Fryar, we look forward to your leadership to be able to connect all the dots. I'm calling from the California San Francisco airport. Uh, so I was glad that you talked about California. You also talked about Hawaii, where I was there about a couple of days back. So all the points are coming together beautifully. So thank you, Joy. So I pass it back to Joy, Dr. Joy said.
Yeah, thank you so much, Dr.
Thank you.
Ghosh. And I think it's just not the connection between many dots, but I think two of the larger dots. So one is Professor Fryer and one is Dr. Ghosh in Boston. I think if these two dots get connected, I think we can derive and we can download a lot of future
Yeah,
of
man.
leadership, which is coming forth and which should come forth just not in theories, but also in practice and also in belief systems. I was particularly taken away when you talked about Saint Francis of Assisi and when you referred to the great examples from Morocco, uh, the Northern African coast, the pre-Incan Andes knowledge, indigenous knowledge systems of using water, and especially the Pablos in New Mexico. We need to learn so much so that we can regenerate the wisdom of the past. But at the same time, your talk also had the latest, that is the use of machine learning uh, to best use the satellite data to understand the discrepancies in our knowledge understanding between recharge on the one hand and its disproportionate relationship with the groundwater which is available. And much of that disproportionate relationship is a reflection of a poor mind or poor interpretation. which your presentation wonderfully brought in the foreground. So I think Professor Gupta is still around. If he's around, and Professor Mukherjee is also around, and so I can just ask any one of them to ask one or two interesting questions. I have not many questions. I have so many observations because I'm particularly impressed because I am a physical planner. I work on environment on the upper surface, and Professor Mukherjee and I, we have done quite a few things together. So maybe Professor Mukherjee, you can ask or you can float.
Yeah,
Yeah,
sure.
yeah, sure,
Thank you
please.
so much. Thank you so much, Professor Sen and Professor Fryar. This was like one of my best lecture that I've heard from you. So
Yeah,
congratulations. Um, so I'll possibly ask a question that is already posted in the chat page, and it talks
right.
about the huge rise in energy extraction and generation and its potential relation to water.
Yeah.
Oh,
Ravi
goodness.
Sitapati. Yeah.
That's an excellent question. I skirted energy and water linkages not because I don't think they're important. As Abhijit, obviously you're aware, and I'm sure others attending, there is a well-established concept of the water energy food nexus, whereby water is needed to produce energy. Energy is needed in some instances, like with groundwater pumping, to obtain water or to move water down aqueducts. Crops are grown not only for food but for biofuels. Um, I think that there have been major advances made with, for example, hydraulic infrastructure with dams. The United States really helped to lead the way in the middle part of the 19th century and the 20th century, the 1900s, and kind of passed the baton to, in particular, India and China in that regard. We talk about hydropower as being relatively clean technology, but as I mentioned, hydropower also has some pretty serious ecological impacts. And so we can talk about other ways in which water could be used for energy generation. I was reading just recently about geothermal energy, for example. You may well be aware of the growth in the United States of geothermal heat pumps, for example, for air conditioning. And so there are multiple ways in which water bears on energy generation. Like with a lot of other things, I think there is optimization that is needed. And just one other comment I'd make, and maybe I'm getting ahead of myself with this, but thinking about Dr. Partha Ghosh's comments and Professor Joyson's comments, I think this isn't the entire discussion here is a matter not simply of systems thinking, but of heart thinking as well. And it's imperative not to lose sight of one for the other.
Right, right. Thank you. I think I think there are questions or observations which are coming on the chat box, and a lot of people have used the same word. Thanks for the insights. Thanks for the great insights. I think the presentation had a lot of that. And there's a wonderful comment from Dr. Ram Ramanan who says, sustainability and spirituality are conjoined twins. I think that's a very interesting, I can put it this way. That's a very lovely comment. Yeah, your reactions to that comment. Yeah, Professor Fry. Yeah.
I would agree with that. And again, some people may say, as people in the United States are fond of saying, I'm spiritual, but I'm not religious. I have no problem with that. I think of, and I'll editorialize a bit here. I think it was Gandhi's quote about, Christianity would be great if more Christians lived what they profess. And so as a Christian, I certainly am sensitive to that comment. So yes, I think that there are multiple ways of viewing things, certainly including but beyond traditional religious perspective as well. But yes, the idea of them being conjoined twins, I think is quite lovely. But hopefully not conjoined in such a way that they need to be surgically separated.
Yeah. I really like that picture, which comes from Ephesus in Turkey, where Saint Paul had moved around, in his sojourns in Cappadocia and in the rock-cut caves of, deep Christian meditation in the very early phases of Christianity. And I think water played a very, very important role along the coastlines of Turkey and of course the water of Jordan. And I was really intrigued and moved, Alan, by your slides on that, your observations on that. And that took me to Abhijit, I, and a few others at IIT Kharagpur, trying to do some work in Varanasi, where the river is just not a flow, but it's divinity itself. It's divinity itself, which connects people, culture, folk, and deep ecology, which is so interesting. Yeah.
And it was my privilege to meet you for the first time in 2017 at the symposium that was based on your work in Varanasi and was hosted at IIT BHU. That was, for me, a profound experience. I still have the photograph of me during the RT on the river that Professor Mukherjee took.
Yeah, absolutely. I think it was mutual. I think we all met at Varanasi. It's like Mark Twain coming from the United States about a century back. And I think reopening what Varanasi is, just not a city, but a water system. It's absolutely a water system. Some questions, I think Ravi Sitapati has also talked about an article which talks about the electricity water nexus, which will test the limits of urban growth. That's very close to my heart because I am an urban and a regional planner, more of a regional planner. I think regions are a little more important than cities. Systems of cities, they are just portions of a huge region, like the Midwest in the United States, of which I'm a part of. That's my second home. About 1/3 of my friends are all there. How do you react to that, Alan? Yeah.
I think that there's a lot of wisdom there. I look forward to reading the article. I actually just went into LinkedIn and downloaded it. And I think I don't want to speculate about the details of the content before I have a chance to read it, but I think the premise is compelling. And I think that, we have discussions, and again, I have to be careful about getting not too far over my skis, as we say in the States, and getting beyond my expertise, but distributed electricity generation, for example, alternate strategies, technological innovation with a healthy dose of sociocultural wisdom is going to be necessary to address these also conjoined issues in terms of electrification, continued electrification, while minimizing water impacts. One of the articles that I read that I didn't cite about technology that I thought was interesting was pilot efforts that are being made in the southwestern United States to put floating solar arrays on irrigation canals to attempt to simultaneously inhibit evaporation in arid climates while at the same time generating electricity.
Yeah, absolutely. And I think one word which really touched me, and I think that's something which is currently missing in an engineering institutions like IIT Kharagpur, is the whole emphasis on cultural memory.
Yeah, I was
And
just going
that,
to add a point on that,
yeah,
if
please,
if you
Professor
allow.
Mukherjee, please go ahead.
So, like just looking through Dr. Fryar's presentation and just thinking back some of the discussion that you and I had about 10 years back, like
Right.
linking the water stories with human history. I mean, the humanity, the from the incubation, from the early civilizations through the ages, and what the lesson it brings to the present and the future. I think it would be a really great opportunity to kind of pin it down to some sort of book, or maybe some kind of commentary to tell the story. Like some of the things that Professor Flash shared, and you and I had gone to the field to look at those things from Nasighat and other places. They have a lot of commonalities, and I suppose people need to read those and learn those
I think
just to know
so.
the future. Just to know the
Yeah,
future.
absolutely. And Professor Mukherjee, you made an effort, which Professor Fryer already mentioned. I mean, that book of yours, which talks about the living memories in the water traditions, which is published. I think there's a very interesting question by Larry Kaufman, and it reads like this: is there a role for industrial-sized desalination plants with large pipe distribution systems to recharge groundwater? Yeah.
I would say, again, with not being expert on this, that once you've invested the energy to um, desalinate saline water, typically that's seawater, but it's not always seawater. Saline groundwater can be desalinated also. That it makes sense to use that water first and then use the wastewater to recharge the groundwater. I think that that's probably a more efficient strategy because you're treating the water really to drinkable standards. Now, having said that, I mentioned that in the pilot scale aquifer injection project in Virginia, and this sort of work is happening also in California, in Orange County in Southern California, um, that water is being treated to drinking water standards direct from sewage. Um, there's something called a yuck factor where people think, oh, I'm drinking treated sewage. Well, in effect, we're all, as someone once said, drinking dinosaur pee anyway. I mean, that's the way the water cycle works. But I think in some ways, it's easier for people to accept um, drinking treated drinking desalinated seawater than it is to drink treated sewage. And so if we're going to re-inject, maybe it's preferable to re-inject treated wastewater as opposed to re-inject desalinated seawater directly. But it's a good question.
Yeah, yeah, yeah. And there's also an observation by Dr. Ravi Sitapati, says that India has huge projects on dam waters and lakes, and perhaps at the same time, lots of solar PV as well as similar systems for reducing evaporation. I think they're like two uh, uh, connects and disconnects. Yeah, yeah, yeah.
Right. Again, getting back to the idea of floating solar, I recall from what I read that that's not the proverbial silver bullet in the sense that there can be some potential water quality impacts from limiting sunlight hitting water bodies. So if you've got if you're inhibiting photosynthesis, for example, by aquatic vegetation, that's not always the best idea. And so I think putting these floating solar arrays perhaps on things like canals where you aren't worried as much about the ecological impacts directly anyway might be preferable, but it's certainly worth thinking about. And again, this is kind of at the margins of my expertise, but I appreciate the thought.
Yeah, yeah. And Professor Fryar, we're also very intrigued. I have not read that book. I'm going to get that book very soon, which is by Peter Glake, the Three Ages. Yeah,
Mhm.
yeah. Probably we'd like to hear a little more from you about that book. And I think such a book will be so interesting because it'll have the narratives of technology on the one hand, and also
Sure.
the dynamics of civilization on the other
I've
hand.
got it's a really excellent overview. I mean, it starts with basically the beginning of the Earth from the formation of the solar system. It's pretty audacious. Peter Glick has written a number of books. This is his most recent. I've actually published a review of the book in the journal Groundwater, for which I'm the book review editor. I've got it on LinkedIn. It's copyrighted, so I don't have it available for public download. But if anybody's interested in sort of my short take, 750 words or so, feel
Oh,
free to.
wonderful.
And Professor Joyce and I'll email you a copy of the review. But anyone
Oh,
else,
that
feel free
is
to message me
so.
on LinkedIn, and I'll be happy to share it.
Yeah, yeah, absolutely, absolutely, absolutely. Yeah, Professor Mukherjee, any other questions from your side? Maybe, yeah.
I
So,
will say
doc,
that
yeah,
um, when Professor Gupta was introducing me and saying that he couldn't count the number of my publications, if I actually numbered them, they would be
yeah,
about half of what Professor Mukherjee has. So
yeah,
I think the
and
term you
that's
used in your email, Joycean, was prodigious, and I would certainly agree with that. I had someone ask me a couple of years ago when I was at a meeting of Fulbright scholars in Kochi how it felt to
yeah,
have a student who was more accomplished than myself. And my response was, I must be doing something right.
yeah, wonderfully said. And I think Professor Mukherjee is silently listening to all that we are discussing and
Well,
saying.
yeah, I suppose there cannot be a greater honor than that. Um,
Yeah,
well, on that note, like I see a lot of students in the list. I
right.
would welcome them, invite them to ask, maybe one
Yeah,
or two questions.
and before we do that, I think
Yeah,
Mark Spencer has an
yeah, I
observation.
see that. Yeah.
Yeah, yeah, and
And
Mark says, very kindly says, the problem in the US is not technology or money, it's politics. In
I agree
Israel, yeah,
wholeheartedly
yeah,
with that.
yeah, yeah,
I
yeah.
think that that's a very salient point. Um, I think that the Israelis, and I think Peter Glick actually highlights this, have been much more efficient, in part out of necessity because they live in an arid climate. But um, Israel was created around the same time as India. It's a relatively young country, and so its legal systems are not as bogged down in things like English common law as our systems are, and it's not a federal nations, so you don't have a bunch of overlapping jurisdictions. But yes, it's incredibly challenging to manage water in the United States because there are so many different uh, political, commercial, social interests.
Yeah,
But
yeah,
yes, to Professor Mukherjee's point, I'd be happy to take any questions or comments from any of the
yeah.
students who
From
are.
from the youngsters who are present here. Yeah, maybe someone can ask or
Yeah,
type.
they're the future. They should be asking.
Yeah, they are the future. Absolutely. They represent the third phase of the water by Peter Lake. Yeah, yeah, the third phase. Yeah,
You
yeah.
have
I
to
think
help clean up our mistakes.
yeah, yeah,
Yeah,
absolutely, 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 and
students,
yeah. So I
would you
think
like to ask a question?
yeah, I
Abhijit's
could
now in the position where he can call out people by name.
yeah,
Yeah,
yeah.
I guess, but I don't want to embarrass them.
Yeah. In the meantime, Dr. Ravi Sitapati also says he agrees to what you says, but he also says, but no more than 65% of the lake surface should be covered. Yeah,
Yeah.
yeah, yeah. And that's what we face in urban planning, in city planning. Eutrophication and the deterioration, the changing character of the lake, the drop in the BOD levels, the COD levels, and everything. So Kolkata is one such victim, because its backwaters should have been the front waters of the city by now, but we could not really do much about the city. You know about Kolkata. You've been here.
Although
So, yeah,
the East Kolkata wetlands are still,
absolutely.
notwithstanding encroachment,
Yeah.
the city's liver and kind of a shining example.
Yeah, it's a part of the Ramsar Convention Act. It's a part of the UNEP Council. I mean, it's covered everywhere, but I think we need to be really careful. And I think you're a very important area of some of the complications that you say. That's the overpumping of groundwater on the one hand, and the salt water intrusion on the other hand. And Kolkata is a bit of that, or maybe not bit. I think it's quite a bit of that. It's quite a bit of that. So there's a clash between the sweet and the salt water, and I mean it has to be handled with very good regional and urban planning. It's happening. Better late than never, but it's happening. But things could have started much earlier. Yeah. So some questions from students. I think they're mesmerized by the wisdom. But I think more than the wisdom, I think if somebody asked me, well, how do you gain? I think I gained enormously. I think the three things. Yeah, the three.
I
Yeah,
do see the name of a student called Sonia, and I know
Sonia.
that
Yeah,
yes, she is interested in atmospheric rivers. Sonia, would you like
right.
to ask a question on that?
Sonia, please type maybe a short question. Yeah. So in the meantime, as Sonia is typing, what I wanted to say is that I was very moved, and I find a lot of hope because Dr. Ghosh and others, we have plans to open up an imagination lab pretty soon, so that we work on our, the other things of technology, like cultural memory, the regeneration of past knowledge systems, and then reflecting back the cyclic knowledge of recovery of water in different shades of controls and communications. So I think that's very, very important. Yeah, Sonia is pretty quiet today. Yeah.
Well, most of them are, as
Yeah,
always.
yeah, it's the end of the day. But I think
Yeah,
we are doing very well with time. We are almost close
yeah,
to 9 p.m. That's the
yeah.
module. It's about just 5 minutes to closing time. But I think this session has been absolutely marvelous, amazing. And for me, it has been a delight because I border on water sciences a bit as an urban and regional planner. And personally, I'm still a student of water sciences. So I think the role of water is absolutely, it's much, much more. And I know the poetries of Tagore, the various mythologies that India has produced over time, they're all based on water. And what I liked in your presentation is that beautiful term, atmospheric rivers. It's, I've really noted that. It really means a lot. And in India, we have a very ancient text called Megdutam, uh, which
Mhm.
is
Yeah,
synchronous to what you have said. So where
yeah.
where the where the clouds are supposed to be atmospheric rivers, and they maintain the hydrological cycle. So they're clouds of yesterday that we
Um,
call
Professor
Purva
Sheth,
Megha.
just thought,
Yeah,
just
please,
as like as you were
please go ahead.
talking about this, I don't know, like if Professor Fryar is having any time, maybe 5 years down the road, um, you might contemplate of getting like a compendium or a book or something, just kind of getting these thoughts on the connection between the science of water, humanity, and maybe even the religion in one under one cover.
Yeah,
I don't know if
that would
that's a
be.
thought that can be
Yeah,
explored.
that's a great idea. That's a great idea. That's a great idea. So
It's putting together this presentation has really stretched me in terms of trying to, make sure that it wasn't simply a jumble of disparate thoughts. So
No, it makes
it's
sense actually.
stretched me
it was
intellectually.
amazing. It was amazing. I just kept a few screenshots of a few slides of yours. That is for my learning, for my learning. I'm going to look
And
at
I'll
it.
be happy also to
Um,
share the PDF of
Yeah,
so
what
yeah,
was being
yeah,
yeah. You can
so
send it
Surya is
to.
asking like if you have the atmospheric rivers, as you said, what is the best way to um, track them, and are they connected with cloudburst in any way?
I wish I had done more homework before I talked about this. So my understanding is that they are um, uh, they're really pardon me, short scale teleconnections. So you're looking at systems that originate, I think, in the Western Pacific and actually pass over the Western Pacific um, to the west coast of the United States. Um, I don't know exactly about how to define them relative to cloudbursts, but they tend to be systems where rain goes on for a period of multiple days in a relatively intense fashion. So when I think of a cloudburst, I think of something where you might have um, relatively intense rainfall, but over a relatively short period of time. Or if I think of monsoon, I haven't really been in South Asia during monsoon. I've really been there during pre-monsoon, but sort of the closest I've come is being in Meghalaya in Northeast India, where the rainy season is much of the year, um, it, starting before monsoon tends to hit other parts of the subcontinent. And really, there are days where you can have tens of centimeters of rainfall over a period of several days. I think the atmospheric rivers are sort of somewhere in between there, as opposed to a single day storm versus an extended rainy season, that these are particularly intense events and they're episodic. I don't know how frequently they occur, but they're not something that happens um, over periods of months, for example. I just don't know as much as I should.
Great, wonderful, wonderful. Yeah, so I think with this, we can just, it's I think a beginning of a new understanding, and it's also a lot of learning from this presentation. I think I'm a student to all that you're saying. Need to understand much more, know things more deeply, and I think same is the feeling with many of the youngsters and the scholars who are a bit silent, but I'm sure the thoughts are in their hearts and they're making a deep well, a well of memory, of cultural memory, which should be regenerating the past to predict a proper future for water sciences tomorrow. And I think this connection which has been offered to us, it's a gift from Professor Dr. Alan Ernst Fryar. It's a Christmas gift right on the eve of Christmas. And I think this gift gives us the tokens, it gives us the beacons, some of the pointers of future leadership that we need in water sciences, which connects the upper heaven with the Mother Earth and brings both the opposites as one integrated whole. It becomes one. So I think such a spirit was evident in Professor Fryar's wisdom cladded, wisdom laden, and wisdom stitched lecture. It was absolutely much more than marvelous. It was much more than just prodigious, and it was just more than just information stitched together. I think today has been an opener to fresh thoughts and really bring out the new avenues of the future to bridge humanity and nature itself. So I think the coming days, we wish you, Professor Fryar, and your family a merry, wonderful Christmas. And all that I can say is just to recollect a beautiful song by Chris Rea, who says, "Driving Home for Christmas." And I'm sure, because in a day or two, I'll be also driving home for Christmas. And I think many of us will be going to the city of Kolkata, which has beautiful shops to celebrate Christmas. And one of that is actually a cake shop, which is run by a Jewish owner, for more than close to hundreds of years. And the bakery is run by the Muslim makers of cakes and pastries. And the people who come for those cakes on the eve of Christmas Day are the Hindus of Kolkata. So I think that is the water science that we think, where the flows, all the waters here and there, they mingle and come together and make that one ocean of truth. And that ocean was visible today in your wonderful, beautiful, mesmerizing talk. So with this, thank you so much on behalf of
And
the
also
School
wish
of
you a happy new
Leadership.
year.
Yeah, Partha Ghosh School of Leadership. Thank you so much on behalf of Indian Institute of Technology, Kharagpur. And thank you so much on behalf of Professor Saibal Gupta, Professor Abhijit Mukherjee, and whatever little feelings I have in my heart. This is absolutely angelic, absolutely angelic. Thank you so much.
Thank you so much. Blessings to all of you.
Happy New Year. Happy New Year to all of you.
Yeah,
Happy New
Happy
Year.
New Year. Yeah. And my regards, our regards to your family. Yeah, to your son and daughters who are coming in. Yeah. Please have a wonderful
Thank you.
weekend. Yeah, please have a wonderful weekend.